back with the revision for the double displacement reaction. But I feel that before I take you to the double displacement reaction, we should revise whatever we have done till now in a quick recap. So we have studied till now that what is a combination reaction. I think you must have understood that combination reactions are those reactions in which two reactants are combining together to give you one product. We also studied about the decomposition reaction in which one reactant was breaking down into two or more than two kind of products with the input of some kind of energy. If the energy is form of light, then it is referred to as the photolytic decomposition. If the energy is in the form of electricity, then it is referred to as an electrolytic decomposition. And if it is in the form of heat, then it is referred to as the thermal decomposition reaction. Please make a note that revising all the examples of these decomposition reaction is very important. Now, the other thing which we did not do in the previous channels were that all the decomposition reactions are considered to be the endothermic. Over here only I will explain you that what do I mean by this term endothermic. The endothermic are those reactions which absorb the energy from the surrounding for completing itself. Like if you look at the decomposition reaction, the reaction was requiring some form of energy input from the surroundings. So those reactions which absorb any kind of energy from the surroundings will be referred to as the endothermic reactions. The third type of a reaction which we studied till now was the displacement reaction. Over here, we have understood that a salt of a lesser reactive element, when it reacts with a more reactive element, the more reactive element will form a salt and will leave the lesser reactive element alone. You should also make a note that all displacement are exothermic. Now, what do we mean by the term exothermic? Exothermic is constituted of two words, that is exit plus therm. Therm means heat and exit you know that going out. So during this kind of a reaction, the heat exits as a kind of a product. So whenever you do this kind of a reaction, the test tube at the end of the reaction will always turn out to be little warmer as compared to the previous condition. So these kind of reactions are also referred to be as an exothermic reaction. Now, what is a double displacement reaction? Now, double displacement reaction is a kind of a reaction in which we will have two ionic compounds which are soluble in water. Though I should not say this sentence because by now you must be clear that the ionic compounds are actually soluble in water. Now, if they are ionic compounds, they should definitely have two things. That is, they must have a positive charge species which is referred to as a cation and a negative charge species which is referred to as an anion. So, if I consider Xa as the ionic compound, then let me consider X to be the positive charge species and A to be the negative charge species. Similarly, in a Yb compound, let me consider that Y is a positive charge species and B is a negative charge species. And as soon as they are soluble in water, they are left into different ions. Now what will happen over here? The ions, the negative anions, that is negative charge species of both the compounds will exchange their positions. Thereby, what we will have now, the new compounds being formed will be Xb and Ya. That means the anions have exchanged their positions. That means the displacement has occurred at two positions. Now, some technical things about the products being formed. What are the special qualities of the product being formed in the double displacement reaction? The products, again, they will be two in number and either one of them should be aqueous. That is, one of them should be soluble in water. What about the second one in that case? The second product being formed in the double displacement reaction should essentially be either the insoluble part, that is the one which is not soluble in water, also referred to as being the precipitate in the reaction, or it can be a gaseous form. Let's look into some examples of the double displacement reaction. The barium chloride, when reacts with sodium sulfate, it forms barium sulfate and sodium chloride. Now please be very careful while observing the states in which the reactants and the products are formed. As already told, the reactants will be two in number and both of them will be ionic and will be aqueous. That means that they should be soluble in water. Now BaCl2 and Na2SO4 are two ionic compounds which have ions as Ba 2 positive and Cl negative. While over here we have Na positive, while SO4 2 negative is the other ion which is present. Now what happened is the anions have exchanged their position. The Cl has taken the position of sulfate and sulfate has displaced the chlorine from its initial position, thereby forming a new compounds as barium sulfate and NaCl. Let's also look into the condition of the states in which the products are present. As already informed earlier, one of the two products being formed will be solid in nature. As they are solid, they will be no more soluble in water. That is, they will settle down, and settling down leads to the formation of precipitate. In this reaction, the precipitate being formed will be white in color. So we will have barium sulfate as a precipitate and the other product, the sodium chloride, will be in aqueous form, that they will be soluble in water. The next important example is where your lead nitrate in the aqueous form reacts with potassium iodide. Again, in the aqueous form itself. Over here as well, we will have two ions, that is the lead ion and the nitrate ion, the potassium ion and the iodide ion. Now what will happen? The nitrate will take the position of iodine and iodine will replace or displace the nitrate from its original position. That is the displacement or the exchange. If I emphasize on this word, that the exchange of ions has taken place. So what is being formed? The formation is of PbI2, that is the lead iodide, which is a solid, settles down and forms the yellow PPT. The other compound is potassium nitrate, which is again soluble in water, therefore should be considered as the aqueous state. The other very important information which you should always keep in mind while analyzing the double displacement reaction, please understand, as already emphasized earlier, that the two products being formed, one of them will always be in the aqueous state. The other product will be in the solid state. But I also told you that the one of the products should either be solid or the gaseous. And if it is a solid, then it is referred to as that the PPT is being formed. Therefore, the other name of double displacement reaction where the PPT is exclusively getting formed is also called as precipitation reaction. So please understand that sometime you will not get the word double displacement reaction in your multiple choice questions. The name will come as this. Suppose this equation will be given and they will not have the option of double displacement reaction. Rather than this, they will have the option of precipitation reaction. So please understand that in double displacement reaction, where the PPT is getting formed, then it can also be referred to as the precipitation reaction. I hope you all are comfortable with the double displacement reaction also by now. Join me for some more practice on the oxidation reduction reaction tomorrow. If you understood the topic, kindly hit the like button. This boost, as always, will keep me going for bringing some more informative videos on this series. Also, do not forget to subscribe so that you get the latest update. The links for all the previous videos will be given in the description box. Thanks you. Keep smiling as always.